This is a video of our Engineering 141 final project. For this project, we had to build a LEGO NXT robot and use MATLAB to program it to solve a Rubik's Cube. When somebody is solving a Rubik's Cube, or at least trying to, they can turn any face of the cube. The limitation of our robot is that it is only able to turn the bottom face, so we have to flip the cube different ways in order to get the desired face on the bottom. A block on the bottom of the rotation tray helps reset it, but it also causes the problem that it cannot rotate freely either way because it hits the wall on the left. We had to account for this flaw when we wrote the code. The cube sides are permanently labeled according to how the cube was set initially. They are labeled top, bottom, left, right, front, or back. In addition to our program, we made 4 functions: flip, hold, rotate, and reset. The flip function does one thing: flip the cube forward using the flipper arm and return to rest. The hold function can either be on or off. Hold on causes the flipper arm to hold the cube, and hold off returns the flipper arm to rest. Rotate can do 4 different things: rotate clockwise 90 degrees, rotate counterclockwise 90 degrees, rotate all the way clockwise, or rotate all the way counterclockwise. Rotating all the way counterclockwise is the default location for the rotation tray. The settings for the longer rotations are judged by time rather than the degrees of rotation, since it has to be able to reset from any position. Reset is by far the largest function. It determines which face is on the bottom and executes a series of rotations and flips in order to reset the cube to its original orientation and the rotation tray to its initial position. Reset is used in between every step in the solution in order to maintain the correct side labels. After the robot scans the cube, it usually gets a few colors wrong. This interface is used to correctly input the cube. After inputting the correct cube, a program begins to calculate the solution. This usually takes less than 2 minutes. When the calculation is complete, it displays the solution using SingMaster notation. The sides are to be rotated clockwise by default, but if an apostrophe is after a step, this means to rotate that side counterclockwise. In this example, the solution is to rotate the downside clockwise, the right side clockwise, the downside clockwise, the front side counterclockwise, and the downside clockwise. Our program reads the solution step by step in order to determine which sequence of functions to use. It first checks if the step is the last character in the solution. If it is, then it is clockwise, and the program executes the correct sequence of flips and rotations according to the side. If the step is not the last step, then it checks if the next character is an apostrophe. If it is, then it executes counterclockwise, and if not, clockwise. After every step, the reset function for that side is executed, so the sides remain correctly labeled.